right, I think we should get started. Welcome to the Data Science Seminar from the University of Washington eScience Institute today. As part of the University of Washington, we acknowledge the Coast Salish peoples of this land, the land which touches the shared waters of all tribes and bands within the Suquamish, Tulalip, and Muckleshoot nations. Today, we will watch together the remaining two presentations from the eScience Institute program, Data Science for Social Good, or DSSG. To remind you, the DSSG program enables research on focused collaborative projects with an applied social good dimension. Each year, up to 16 student fellows can participate. If you're interested in the program, please visit the eScience Institute website for more information. Today, we will be hearing from the remaining two DSSG teams and their projects that were developed as well over the summer of 2022. The first team explored new understandings of the cost of living at a basic needs level using the Self-Sufficiency Standard database and was composed of fellows Aziza Mirsaidova, Priyana Patel, Cheng, and Hector Sosa, and coordinated by the eScience data scientist, Dr. Brina Hazelton. The second project presented today from the DSSG program is titled Tracking Family and Intergenerational Poverty Using Administrative Data. Team members for this project include Chaowen Guo, Ihsan Kahveci, Bethlehem, Aklilu Muna, and Elliot Stanton, and were coordinated by Dr. Jessica Goodwin. As usual, please use the Q&A feature of the Zoom webinar version to ask questions. Also, please ask questions after each of the presentations. We have here Aziza and Ihsan today with us, and they will address any questions you may have. And with that, I would like to ask Luisa to start the presentations.
Understanding
yes,
of cost
thank
of living
you.
at a basic needs level using the Self-Sufficiency Standard database. So the fellows were Cheng, myself, Priyana, Aziza, and Hector, and our project leads were Annie Kuklik and Lisa Manzer from the Center for Women's Welfare in the School of Social Work here at the University of Washington. And our data scientist was Brina Hazelton from the eScience Institute, also here at the University of Washington. So I'm first going to start off by talking about the U.S. official poverty measure. And so the official poverty measure sets eligibility for critical benefits such as food assistance, childcare subsidies, or housing vouchers. Many families, however, cannot afford their basic needs and are not considered in need by the U.S. official poverty measure. And so how it's measured hasn't been changed since it was created in the 1960s, and it doesn't vary by place. So the poverty line is the same for Mississippi as it is for the state of Washington. So the Self-Sufficiency Standard is a budget-based living wage measure that determines the amount of income required to meet basic needs at a minimally adequate level. And it was created by Dr. Diana Pierce at the Center for Women's Welfare to provide an alternative to the official poverty measure. And so it includes the costs for the basic costs for a budget, but it does not include luxuries such as eating out, and it only includes what you need to get by without the use of subsidies. The standard is calculated for 42 states here in the United States, and the Center for Women's Welfare strives to make the standard as consistent and accurate as possible. So the data used to impute the standard is calculated and collected using standardized or equivalent methodology nationwide. It's obtained from scholarly or credible sources such as the U.S. Census Bureau. It's updated regularly, and it's geographically and age specific as appropriate. So who utilize and interact with the Self-Sufficiency Standard data? So community organizations, academic researchers, policy institutes, legal advocates, training providers, community action agencies, and state and local officials are just a few of the people who utilize the data. And they can use it as a policy analysis, a counseling tool, an evaluation tool, a benchmark for wage setting, targeted allocation of resources to further research, and also as a community indicator. So for this project, some of the community partners that we spoke to include the Workforce Development Council of Seattle-King County, and they utilize the standard to provide financial counseling to their customers. We also had conversations with the Colorado Center on Law and Policy, and they use the standard to advocate for better wages and to support employment. And in addition to our partners, we heard more from Dr. Pierce, the founder of the standard, who utilizes the tool to validate costs for testimony as an expert witness in Congress. And lastly, we spoke with our project leads, Annie and Lisa, who are researchers here at the Center for Women's Welfare, and which ultimately manages the standard and its data. And they were the primary stakeholders for this project. And so while we weren't able to speak with every partner, the Center for Women's Welfare utilizes has a breadth of partners who utilize the standard to further their work in their respective states across the country. While the self-sufficiency standard data is open and publicly available and also readily used by its partners, the workflow to transform the data is inefficient and hard to reproduce, and this makes it difficult to conduct deeper, more novel analyses. So the current challenge with the data is that it's spread across state and year in separate files and locations on the self-sufficiency standard website. And while the files are extremely standardized, how the data is formatted makes it difficult for automated analysis. And this is, for example, because there could be duplicates or spelling errors. And then when conducting analyses, because they're done manually, it requires manual validation to check that everything was transferred correctly, especially when copying and pasting from tables. And because of this, it's difficult to track the workflow and the specific steps that are taken. And this evidently takes significant time to complete. So for reference, the Center for Women's Welfare conducts a city comparison, and we'll actually talk about that more later in the presentation. And right now that takes about 3 to 5 hours to conduct. And then lastly, another important thing to note is that these certain type analyses, such as the city comparison, are only conducted and changed by experienced researchers. So there's essentially a bottleneck in how many people can utilize the data and the standard itself.
So this leads us to our research question: how can we store self-sufficiency standard data to increase the efficiency for stakeholders to use the data and extract meaningful information and conduct novel analyses? So for this, we performed database development process, which actually consists of 4 main parts, including the preparation step. So initially, we conducted stakeholder meetings and further research to be able to understand the columns and their relationships better. So in order to store the data from all the files in one database, we preprocessed the files to standardize the column names. Then we created the relational model schema that arranges the data in a series of tables, rows, and columns with a relationship between tables. And then we use the Python to read the data from the Excel files and do cleaning and pre-processing. So we use SQL Alchemy to create database tables and insert the data from the files into a SQLite database. So this is actually our final result for the database schema. So in the self-sufficiency standard data, most of the columns are consistent among files, but there are a few columns that contain extra information and they're only present in some files. So in order to increase the efficiency of accessing the data, we created one table with the data that is always present, and 3 helper tables, which are GeoIdentifier, CT, and Puma, to contain extra information that is only sometimes available. We also added Boolean columns to the main table, which are healthcare, miscellaneous, and ARPA, to the main table to indicate when the extra information was available. And the or family type, state, place, and analysis type that it was same across the main and helper tables to make it easy to link the data across tables.
So as we have like the supplement information that is not come from the original goal of this project, but during our discussion with our stakeholders, we kind of inspired by their ideas. We saw the possibilities that researchers can conduct other or supplement research and measurement based on this open data sources. So for healthcare, miscellaneous, and ARPA, as Aziza mentioned before, this data are originally come from the self-sufficiency data set. And the PUMA city county, the city table and the geo-identifier is come from the census HUD or CPI data set. Mostly for the PUMA, for example, the PUMA is the full name, PUMA is the short name of the public use microdata areas. And we link to the ACS data set, which is American Community Survey, a part of the one kind of the census data. And this data, this combination make it possible for us to compare, for example, the percentage, the population percentage above and below the self-sufficiency standards across some kind of like areas. And the city county, the city table, we refer to the city county crosswalk table since most of the standards are county based. And if we want to compare the city, let's say Seattle and San Francisco, we need to go back to see which county this city belongs to. So this crosswalk table make it more efficient to compare the cities about the self-sufficiency standards. The geo-identifier is easier for us and the researchers to compare the CPI and the inflation adjusters across 5 years when the CPI changes, and the report date is mostly for the log purpose when the database updated.
So one of the key goals and ethical considerations of this project was providing transparent processes for our project leads and our community partners with varying technical backgrounds. And this was to ensure that the workflow and analyses are reproducible beyond the scope of this 10-week project period. So to do so, we provided rigorous documentation of our code in the form of markdown files on our GitHub repository. And this was split up into 2 parts. So the first was how to set up your technical environment. And so this includes downloading the specific software and initializing the database. And the second part was how to insert and retrieve data. And so specifically how to pass files into the database.
And based on the documentation and improved workflow, those responsible for conducting analyses will be able to produce analyses which are now more reproducible because a lot of the operations are more automatic and less manual driven. And I'll give an example of how the workflow has changed before and after the database. And in addition, with the database, we, the fellows, were able to conduct analyses that were not possible prior to the creation of the database. So for the workflow example, we're specifically looking at analyses across cities, and we're interested in comparing similar sized US cities across time. And before the database, this was only done at one point in time, and it was across only one type of family type. As you can see in this map, there were only family types listed for 1 adult, 1 preschoolers, and the self-sufficiency wages needed for that specific family type. And this was the workflow to create the map just shown. The person responsible for creating this analysis would have to open 16 files, which was for 4 cities across 4 different years because of how the data is stored. And from there, click on filter settings to get the specific family type and copy and paste the rows of interest into a new file to create visualizations of interest. And overall, this workflow took about 3 to 5 hours to complete. However, now with the database, this process is a lot more shorter. And specifically, we would just call the database and retrieve the information and the information of interest and run our code. And this would take 5 minutes. And another thing to note now with the database, and as I mentioned earlier, this work is more reproducible and applicable in other settings because you can just change a couple lines of code to retrieve the same type of information, but let's say for different states. Okay, so what we have here now with the database, we are able to compare several cities across different years and include many different family types. And prior to the database, this was not possible. We were only able to look at one specific year and one specific family type across several cities. And now, because of our detailed documentation and improved workflow, we are now able to reproduce these analyses in different settings. And one analysis of interest that we conducted was comparing graduate student salaries to the self-sufficiency standard. And specifically, we were interested in looking at single adult PhD student wages to the self-sufficiency standard across across 2 different universities, across 2 different years. And as you can see, it's not enough. So what we have on the left here, what we have on the left here is the self-sufficiency wages for King County, Seattle for a single adult. And then we have in the gold UW's PhD student wages. And on the right, we have the self-sufficiency wages for the Los Angeles County for one adult in purple. And then we have UCLA PhD student wages in the light blue across 2 different years.
So we also conducted additional analysis in terms of gender wage gap. So since the earnings gap between men and women varies by state, how is the gender wage gap impacted by the difference in the cost of living as defined by the self-sufficiency standard data? So we conducted analysis for 3 household types where there is one adult, as you can see here, one adult and one preschooler, and another one is one adult, one preschooler, and one schoolage. As an engineers, we were interested in analyzing the cities that are hubs for technology. Thus, we chose King County, Seattle, and San Francisco County, which encompasses itself only San Francisco City. From the analysis, we found that both female and male adults living alone can afford themselves in both cities. However, when a child is involved, single mothers cannot afford one preschooler in both cities. So while single father can actually afford one preschooler plus one schoolage in both cities, so this actually clearly shows that there is a greater impact of gender wage gap in cost of living.
So we also, according to this database, we are able to create a live interactive website, a map, which if you click, it will compare some kind of stuffs. And this is the first ever we could compare the self-sufficiency standards and the poverty line nationally. And if they are empty of the polygon, which means we did not collect the data of the state, which is empty. And the area with deeper purple, and which indicate the higher percentage of the population below the self-sufficiency standards. And when we click one polygon of a state, it will pop up the information of the percentage of population under the self-sufficiency standards and the percentage of the population below the poverty. Like around 20% of the population below the self-sufficiency standards, but only around 6% of the population below the poverty line. This is also echo of the claim we have before. There's a big gap between the self-sufficiency standards and the poverty line. And moreover, if we zoom into one state, let's see, we just picked the Puma area, which is the University of Washington located. And the percentage of self-sufficiency standards and poverty line will, for this specific Puma, will pop up on the top right. Yes, this is kind of mirror here. Take an example for this area, if like 2 adults and 1 infant, maybe like a graduate student's family, and the self-sufficiency standards is around 78,000 for for enough because self-sufficient, but the poverty line only claim 22K, which is much lower than the self-sufficiency standards.
And so because this is an ongoing contribution to a long-term project, we wanted to envision how the database will live on in a visual and accessible format. So this is a dashboard designed for a general audience to explore the standard in a more digestible format. So what's made easier here is that you can clearly see the database structure, the table you're accessing, and then you can explore the standard for specific states, counties, years, and family types. And then after that, you can easily drag the values to what you would want to visualize in a plot. And while this is just a concept design, it can be handed off to the Center for Women's Welfare to build as the database gets further developed. And that is the end of our presentation. Thank you to our sponsors. And if you would like to interact with the national comparisons map that Cheng shared, we have a tiny URL at the bottom.
Thank you. Please don't forget to ask questions. Aziza and others can answer the questions you may have on this presentation. I know that there are some black boxes on the screen. I think these are all due to the way we're sharing the videos with you. I don't think we should do anything about them right now because that will take us some time to remove them, and we don't have the time today. I think we'll suffer through them. Somebody, Rachel, is asking for the URL for the Self-Sufficiency Standard database. Is this available?
Yeah, I pasted. I'm not sure for the panelist mode whether everyone can see the post. I mean,
you can
the
paste
URL.
it in chat.
The chat is only for hosts and the panelists.
If you choose everyone, I think everyone will get it when you type your message.
I cannot choose everyone actually.
All right, can you send it to me and I'll try to.
Yeah, I send in the chat box.
Excellent. I will paste it in chat as soon as I can.
Mhm.
Oh, we can see it. We can see the reply. Okay, excellent. They got it. Are there any other questions for our DSSG fellows today? How was the UW PhD student salary calculated? Is the question from Alyssa. Can you address the question, Aziza or?
Aziza, do you
Cheng?
want to say something?
Yeah, so it's conducted. So one of our members, so he did this research. So he basically compared the graduate student salaries to the self-sufficiency data. And so he did it based on single adult PhD student wages to the self-sufficiency across universities and the years. So he specifically chose Seattle and the Los Angeles County. So he basically got two of the the self-sufficiency data. If you want, we can also come back. Maybe it was like in the middle, they can see the plot again. So basically they compared the self-sufficiency wage to the University of Washington PhD wages, and another plot was about the self-sufficiency wage and as well as the UCLA PhD student wages. So that's how, if you have these two plots, you can see the differences.
Yeah, and since the PhD salary is most of the, especially for the public universities, they have a union. So the pay rate for the PhD is kind of public data.
And then understanding, like comparing to actually to self-sufficiency kind of provides more direct information. For example, self-sufficiency is actually how much do we need to be sufficient, right? Like And this is really applicable for the single PhD student. So that's why our teammate conducted this research.
All right, thank you very much. And I think we're moving on to the next one. We're a little bit behind today. Thank you, Aziza and Cheng, for joining us today and addressing the questions. We had more questions, but we will reach out to you later on. So thank you, Luisa. You can start the next one, please. Thank you.
Okay, thank you. A little bit bigger. Thanks. Yeah, you're welcome. All right. Can I start? Okay. Hi, everyone. We are the Tracking Poverty team made up of Jawen, myself, Bettelhem, Ihsan, and Elliot, and our project lead was Jenny, and our data scientist was Jessica. So we're going to just give you some introductions and then go into the two approaches that we did, looking at one looking at multiple definition at 1 month, and then the other one looking at time, looking at one definition across time, and then looking at and then ending with future work. So our purpose was building households and families out of individual level data. So why do we care about households? Let's say we have two individuals. One has an annual income of $15,000 and the other one has an annual income of $100,000. If they were unrelated, one would be under the poverty line and the other one would be considered non-poor. But if they were related, they both would be considered non-poor. Poverty is a household level construct. It looks at pooled resources. So when you think about questions about poverty, we're thinking about who is sharing those resources. And this would allow us to answer questions such as like the impact of the Seattle minimum wage, which and its impact on the poverty rate, which is one of the longer term goals of this project. So what is a household? A household is defined in many ways. The census defines it as a people that occupy a housing unit, and they can be related or unrelated, but kind of puts it into two categories of family and non-family households. Additionally, we found when we were like looking at different organizations, one defined it as people that buy groceries and cooks together at a residence. So it's really nuanced definition across people. And then socially, there are like our age, our marital status, our immigration, race, class, really influence how we think of our own household, our family. So our goal was really to think about how can we get to a point of this is a resource sharing unit or economical unit that really represents as much the complexities of society as possible. So here we're looking at residence as a physical household, family is like a relational household, and household as defined in multiple ways across the spectrum of residence and family. So we use the WMLAD or the Washington Merged Longitudinal Administrative Data Set, which was created to examine employment and earning outcomes. And it got information from across 6 state agencies, about 10 million people across 96 months. And it was not collected for research purposes. And that's something important to know. And it also, like, some agencies cover some subpopulations more than others, but collectively they give us a really, it was very informative for us to know who was in the data and also consider who else was missing from the data as we went on to do our analysis. And then on the second section, we looked at previous work by Jenny and many of her colleagues, and when they looked at, like, we focused on these two that they looked at, which were the recorded addresses, which looked at sporadic address records from months that people interacted with the agencies, and then used that to create estimates and replace the missing addresses across the 96 months to get more the likely or imputed addresses, which we then used as our starting point to kind of improve upon using 2 different methods, the point in time and the longitudinal method. So while we were doing this, we had to recognize these are people that we are talking about, and we were always trying to think about the ethical considerations with using administrative data. We were always trying to think about what are the different definitions that would consider the atypical households as best as we could, as well as thinking about using the enclave and layers of anonymity to maintain security and privacy of the data, and then thinking about having detailed documentation and holding ourselves and each other accountable to use this data for public good, but as well as consider this is people that we're talking about. So this is like what we saw in week 2. There's a lot of like the whole like big chunk of the summer we just used to try and understand what was there. We had some guidance, but really we spent a big chunk of it trying to understand what the structure of the data sets, distinguishing between the important variables and non-important, like for our purposes. And then from that, we kind of created a schema to really pull out the ones what we wanted to focus on, which was focusing on demographics, the imputed address codes, last name codes, and like social services, and kind of just looking at the relations between them, get rid of redundant information, and then cleaning the data, and then putting this into a database that we could use to look at households, as well as future people can use.
All right. So we took 2 main approaches to creating households. The first we called the point in time approach. And in this, we consider just 1 month of data at a time, and we add on 1 variable at a time. And at each stage, we subtract out the households that are clearly defined enough, and we don't need to consider them anymore. So we started with address information, and then we considered last names in 2 different ways. And after I talk about that, Jawan will tell us about our longitudinal approach, where we consider address information over multiple months. So we take our population, and we start by grouping them by address, both the recorded addresses and the imputed addresses. And when we do so, everything becomes more clear. In this case, you can see 5 people share an address identifier in our data at a given month. And our first definition uses this residence as its only input, and the output is that it's a household. So this sort of follows the census definition, where people who live together are a residence or household together. And this actually is the basis for our other definitions, in that only people who live together at the same time can be a household. The census works this way, and so do the rules for different anti-poverty programs that we have data on. But what this definition doesn't capture is, are these people roommates or are they family? If we assume that they pool income together, we could miss some people living under the poverty line. So we want to get closer to measuring a family, or more accurately, a resource sharing unit. And to do so, we try to infer relations from the data. One limitation of this, we are looking only at a single address at a time. And so we're not identifying resource sharing with dependents who live elsewhere, even though we know that that takes place. But instead, we're dealing with cases where people live together and may not be sharing resources. We have limited data options to choose from here. We don't have marriage licenses or much information on children. And we have to be really careful with using demographic data like race and sex, which covers almost everyone in our data set. But inferring relations based on these categories would just reinforce heteronormative, racially homogenous traditional family notions. So instead, we look at last names. Why? If people share a last name and they live together, we're pretty certain that they're family. And we have one in our data for almost everyone. We also found that 63% of the naive households have only 1 last name. This does include people who live alone, but it's still a pretty large part of our data that we were able to take out of the picture. So now we see we have 2 clear cases. There's 1 last name in the residence, or there are multiple. For the first case, we preserve the naive definition, and we consider them completed, which reduces computation time in our further exploration and decision-making. For the second case, we take 2 approaches. The first is deterministic. And in this approach, we split the multiple families up at the single residence into separate households by last name. However, we know that many families have multiple last names in them. So to address this, we use probability to decide between the 2 options, keeping them together or splitting them up by last name. And we do this with a weighted coin flip. We weight the coin based on the census likelihood that a residence is a family or not, by household size and region. For example, in this case, we would look at 5-person residences in counties A and B, and maybe county A has 80% of them as families, and county B has 20% as families. So those are the weights for the coin flip. And we could get a lot more granular with these probabilities, incorporate age information and census microdata, tailor to more specific cases with the number of last names in the household. But this is as far as we got, and the code is set up so that it's easy enough to adjust these probabilities in the future. And here's a quick recap of our household definitions. We have naive co-residence and last name definitions, both deterministic and probabilistic.
Hi again, this is Ihsan. So sorry for your eyes to making you look at the table with a lot of numbers. It's my bad. So what we're gonna do today, right now by my section, I'm gonna show you some of the distribution of how households differ based on our definitions, and we're gonna compare the census data. But I need to tell you that there's not an actual grand truth comparison for this kind of research. So we can test certain definitions do well on this kind of comparison to census, certain does not well. The whole idea is depends on a research question, and the way you want to calculate poverty is which definition or what type of way to look for. So in this case, we only compare census, I'm sorry, I have to repeat. So this is for all Washington states, for all families, all households, whether a family or a non-family, and their distribution across household size, 1-person families, 2-person families, to 7 and plus more. The reason for 7 plus more is just came from census. And so in order to make the comparison, we have to lump them into the same category. So what we understood is here. So if you remember naive co-residence, basically putting people who live in the same time and address into each other, this should make the census process as close as possible. But the problem is here, as you can see in the first household size, we have overestimated these people in terms of percentages. And the reason for that is most likely we don't have the children data. Here's an example. We see a 1-person, maybe a single mother with a child that we don't have in the data. We think they're a 1-person household, but in reality, they might not have to be, or they might not be. But in general, as you can see, and especially in larger household sizes, the percentages are a lot closer and the counts are a lot similar. Especially this is like very similar in 3-person households. I don't have an exact reason why 3-person households are like better off than 4. Probably just chance. But as the number of household sizes increases, these numbers, so you see the drawbacks, pros and cons. But as Elliot mentioned, the other thing we need to decide, okay, we can divide people into smaller groups, but how can we decide whether they are families or resource sharing units or not? And that's the second comparison. And this time, instead of looking at, unlike here, the all family and distribution of across sizes, we're looking at the census, I'm sorry, I should have said decennial census 2010. Census is not one thing, there are a lot of census data. It's US, because our data covered from 2010 to 2017, the only decennial census data with exact counts but not uncertainty came from 2010 census tables. And moving on, we'll look at the family, what census called family households on the first axis in here. So these are the percentages of, and that's why we don't have a 1-person household, because census doesn't label 1-person households as families. And the first thing, if you remember, the last name, if you just disaggregate co-resident people who are co-reside, staying together in a given month, you will have a lot of 1-person or like sorry for echo, 1-person family is going to pop up because you don't know you haven't done anything with them. But that has some advantages that you will never, at one point you will get very granular, but at the other thing, you will probably miss a lot of people who can be a family but not share a last name. So the good thing in here, when you take just the mere tract level, tracts is a geographic unit, is smaller than the county, but bigger than the neighborhoods. You can refer them as blocks, neighborhoods, so it's bigger than neighborhoods. And you can reduce the discrepancy, and you can have a better distribution, and they can match better. And even this like simple taking up the probability, adjusted probability, once you label the ones that you already know of, the numbers match slightly better. And this, but as you see in here, as the size increases, and as you can also see in here, as size increases, what you see in here, you take 1 or 2 people households, probabilistically you put some of them as higher families. Actually, we're not putting them in here, we put them non-families, but the ratios change so that you have a better distribution. Sorry, I should have been more clear about it. But the case in here, what happens to 1-person families? We will have much more discussion when Javan talks about it, but I want to show you an evaluation of this. This is Seattle metropolitan area. And this is, so this map shows you whether we overcount represented as red, whether we undercount Oh, right, okay. It's kind of weird. Whether we undercount based on blue. So the color should be the reverse order. I'm sorry, I was confusion. And we have like some form of a vague confidence interval. Basically, if we miss between 2.5% below and above, we count it as, we say it's within the error range. So you see them as white. And in most of the Seattle, you can see that they're red, so we overcount one-person households, which makes sense because I have to remind you, this is for just co-residents, and this makes sense because we have missing data on children. But when you go back to the downtown Seattle area, where we know that from census, we know a lot of one-person households leave, we are undercounting. Even with a definition that we hoped our count than undercount, we are still undercounting in the one-person families in the downtown area. And this where we see the likeness of one point in time approach, and we will introduce you why we should look at this problem longitudinally.
Additionally, we look beyond point in time and incorporate longitudinal household changes to improve our imputed addresses. To begin with, we compare the distribution of households by size using census and our naive co-residents from WMLAN dataset, and found that we overestimated one-person residences and underestimated the others. To explain why this happened, we looked into specific scenarios regarding these one-person residences. In the first scenario, we observe one person living alone for a few months and then start to live with others within the same address. This is likely to happen when the added person is a child who interact with government agencies less frequently than adults. For example, only when the child registered to vote or get their driver license would they leave an administrative record into our data. In this case, we want to make a revision to reflect reality. For the second scenario, we observe alternately appear pattern of one-person residences and the other multi-person residences that the person belongs to. We believe that these frequent movements into and out of the same address are likely to represent an imputation error, and we want to revise these one-person residences accordingly. For the third scenario, we observe two persons living together for a few months, and then they start to separate from each other and reunite again in a new address. We believe this corresponds to the case where members of a household move out at the same time, but their addresses were not updated accordingly. In this case, we want to pool these one-person residences together in the transition period. However, here is a case we don't want to make a revision, which is when the two persons who used to live together for a few months, and once they move out, they no longer live with each other. We want to leave their observations as they are, which means we only want to make a revision when the co-residence before matches the co-residence afterward. Taken together, we want to revise the one-person residences, taking into account the following scenarios: lack of interactions, imputation error, and moving in and out. After implementing this modification algorithm and removing duplicates to make sure that each person only appears once in a given month, we found that the proportion of one-person residences went down to 31%, which looks closer to the census data. So to summarize what we have done throughout this program, first of all, we created a relational database for future WMLAN users with all data in a clean and well-structured format. And we also apply both point-in-time and longitudinal approach to derive and improve household and family identifiers. We believe our workflow and data output can be used for future researchers to answer questions at the household level. And admittedly, our work is subject to some limitations. One of the limitations is that we only apply the longitudinal approach to household of size 1, and in the future, we hope to extend the logic to households of larger sizes, while integrating point-in-time family information and longitudinal corrections. Moreover, we hope to incorporate other information such as social networks, demographics, and anti-poverty programs to capture a diversity of households. In the end, we want to thank everyone that supported us and our work throughout this program, and we look forward to your feedback.
All right. Those were the presentations for today. If you have any questions, please use the Q&A button. Ihsan is here today and will help address the questions if you have any. Maybe I will ask one while we're waiting. I think I saw that at the end, the idea that this work will be available to other researchers to use. And I was wondering, how do you plan to make the database available, and where should people go and look for it, or for how you would disseminate your work through the academic environments or outside?
Am I audible?
Mm-hmm. Yeah.
Thanks for so unfortunately the data the prototype and the data is not publicly available. So everything is done in a secured enclave in Europe, and there's a team of researchers that works for the PI like on a regular basis, and this will be a continuing project. And what we hope to just create a research prototype with like certain tools and analysis that they can redo and over and just come up with new analysis. And again, the database is also internal. To get the data, it's just there's like a huge process of getting IRB approval from the state, from the UW side, and that is something the School of Social Work and CSD handles. So yeah, our audience are actually pretty limited, like at most 50 people right now.
All right. Thank you. I think we'll end here because we're a little over. Thank you for your patience with our audio and video challenges today. Enjoy your evening, and we'll see you next time. Thank you.